In this video, I'm going to show you how we can perform chi-square test, chi-square test of significance, right? And I'm going to teach you one of the tricks available in the IBM SPSS where you can try to enter secondary data. Ideally speaking, you should we assume this frequency number 25 as 25%, 75%, 10%, and 90%. So ideally speaking, you have to include individual datum in the datasheet. So you have to incorporate all. But to simplify the matter, say for example, you have a secondary data like this. So you have male that engage in aggressive driving as 25%. 75% of males do not engage in aggressive driving. 10 female engage in aggressive driving, and 90 female do not uh, engage in aggressive driving. Okay, so under default condition, the IBM SPSS does not allow you to do secondary data analysis, but this is how you can trick the IBM SPSS so it can provide that kind of assessment. But for the purpose of research, as a supervisor, I always like to see the crude data. I do not want it to be in this form. But for the purpose of showing the analysis, I'm using this to simplify the matter. So how to trick the IBM SPSS? First, you have to click data and then click weight cases, right? So weight cases by frequency. So now you click OK. You can see that the processor ready, and when you look at the what we call dialog box, okay, you see that wake on is the status is wake on at the bottom of it, right? So now the computer is recognizing this 25 as not as an individual entry of data, but as 25 people, 75 people, 10 people, and 10 people. So the computer is recognizing that way now. So to perform this chi-square test, you click Analyze, you go to Descriptive Statistics, you go to Cross Tabulation. Okay, so you transfer aggressive gender into row and aggressive driving behavior into column. Leave the frequency case in that initial box. Okay, don't change anything exact wherever you don't change statistic. Okay, you must click chi-square, right? And I'm going to click Phi and Kramer because this is actually the effect size, which is going to be very useful for you later on to design your experiment. This is the effect size. Okay, you click continue, and then you click cell. You make sure you click observe and expected, and then percentage in the row. Okay, click continue. Format, okay, do not change that, and then you click OK. So it is good that the case processing summary does not indicate any missing data. That's very good, meaning that every single entry was actually computed by the computer. If you look at the end value now, it is indicating 200 people, okay? Because you already told the computer that the values entered are frequencies rather than individual set of data entry, okay? So now we go to the third table first, right? As you can see, the Pearson chi-square, the p-value is 0.005. So meaning that there is a significant association between the two categorical variable, the gender and the driving behavior, aggressive driving behavior. So there's a significant association. So as for the chi-square, you are actually looking at associating two categorical variables to see whether they have such influence on each other, right? So in this case, gender is actually the independent categorical variable. So now when you look at the table, look at this first column. Okay, you can see that count, expected, and percentage within gender, right? So you can see that this is very important. You look at the expected count, 17.5. Expected count 17.5. they come up with 35 because 35 divided by 2, you get 17.5. So 17.5 means in order for the association to be not significant, the count value must not exceed 17.5. Okay, for the case of female, the count value must not exceed 17.5. All right. So in order for us to say that there is a strong association in aggressive driving behavior among male and female. But when you look at the actual count, 25 males are actually committing aggressive driving, 75 do not, right? So this 25 is way above 17.5. So this would indicate there is a strong association, a significant association in gender when it comes into aggressive driving for the male. However, the count value for the female is only 10, way below the expected count. So we can say that female do not really engage in aggressive behavior. All right. So that's how you can come up with your conclusion. So there is a strong, significant association between gender and the aggressive behavior. So male tend to commit more aggressive behavior in driving when compared in relation to the aspect investigated. All right. I hope you understand the explanation.